Cisco just released security models tiny enough to inspect a codebase locally. The surprise is not another chatbot, it is a focused agent trained to answer one expensive question: where should a reviewer look first? The family is called Antares. Cisco released Antares 350M and Antares 1B as open-weight downloads on Hugging Face, while a stronger 3 billion parameter version was announced but had not been released at publication. Antares is not trying to write your application, debate architecture, or become a general coding copilot. Its narrow assignment is vulnerability localization. Connect a security description to likely vulnerable files inside a repository. That word matters. Localization does not prove a bug is exploitable, and it does not automatically repair anything. It ranks candidate files so a human or another security tool can investigate with less wandering. Real vulnerability triage means entering unfamiliar code, tracing calls, decoding naming conventions, and comparing plausible locations. The relevant evidence may span several modules, while the advisory rarely hands you the exact path. Hosted models add another concern. Source code may be proprietary, regulated, or simply too sensitive to upload. A compact local model can keep repository contents inside the developer's machine or controlled environment. MarkTechPost reports that both released models and the benchmark use the Apache 2.0 license. That makes experimentation unusually accessible, although open weights still do not guarantee easy deployment, good results, or zero operational cost. In the reported evaluation, the agent begins with a CWE category description and a repository snapshot. It receives no advisory narrative, severity clue, or convenient file hint pointing toward the answer. The model issues read-only terminal commands, searches for relevant patterns, opens candidate files, absorbs the evidence, and changes direction when a lead looks weak. This is learned repository navigation, not one giant prompt. According to the technical summary, each benchmark task allows 15 terminal calls inside a network-disabled Docker sandbox. Command output is truncated before returning to the model, forcing exploration under a tight information budget. When finished, Antares submits either a ranked list of suspected file paths or no vulnerability found. It also preserves the terminal exploration trace, giving reviewers a route to inspect rather than a naked verdict. That trace may be as valuable as the ranking. Security teams can see which terms were searched, which files were read, and where the model backtracked before deciding whether its conclusion deserves trust. Cisco created the Vulnerability Localization Benchmark because general coding tests measure different skills. Fixing an issue or locating a feature is not the same as finding vulnerable files from a weakness category. MarkTechPost says VLOC Bench contains 500 tasks from 290 public repositories, spanning NPM, pip, Maven, Go, Rust, and Composer, with 147 distinct CWE categories represented. The reported ground truth comes from security patches. Source files changed by the fix become labels, while tests, documentation, and configuration are excluded. That is practical, but still an imperfect proxy for vulnerability location. On Cisco's benchmark, Antares 1B reportedly reached a file F1 score of 0.209. GPT 5.5 scored 0.229 in the same setup, leaving a real gap, but a surprisingly small one. The secondary analysis reports Antares 1B above a 753 billion parameter open-weight model that scored 0.186. That does not make Antares generally smarter. It shows how specialization can overturn parameter count expectations on one task. Antares 350M reportedly scored 0.135, ahead of several much larger comparison models on this benchmark. For perspective, 350 million parameters is tiny by modern language model standards, but tiny does not mean universally capable. The strongest clue is the baseline. MarkTechPost reports the underlying Granite 4.0 checkpoints scored essentially 0 in this agent setup. Tool access alone achieved nothing. Targeted post-training created the useful behavior. The reported supervised dataset leaned heavily towards cybersecurity reasoning, with smaller portions for code search trajectories and broader research reasoning. The recipe taught not only vulnerability concepts, but how to move through evidence. A reinforcement stage then rewarded localization quality, valid submissions, compliant tool use, and exploration while penalizing malformed output. Reportedly, this improved scores and reduced run-to-run variance, potentially important for repeatable automation. Cisco's bigger argument is economic. A focused small model can search continuously without paying frontier model prices for every repository. That could make per-commit triage realistic for teams with limited hardware or security budgets. SiliconANGLE reports Cisco estimated a full benchmark run below $1 for Antares versus roughly $12.50 for its strongest open comparison and $141 for GPT 5.5. Those are evaluation estimates, not your guaranteed invoice. Hardware ownership, electricity, quantization, orchestration, engineering time, and utilization all change local economics. Free weights are not the same thing as free operation. Running locally removes a major data transfer concern, but privacy still depends on the surrounding system. Logs, telemetry, container mounts, cached prompts, and build artifacts can leak code if the deployment is careless. The results also come from a benchmark built alongside the models and reported by Cisco and secondary coverage. Until independent teams reproduce them, treat the numbers as promising evidence, not settled reality. MarkTechPost notes that published Phase B false alarm numbers were absent. Finding patched repositories clean is crucial because a model that always names suspicious files can look helpful while burying teams in noise. Antares 1B reportedly achieved the highest recall among evaluated systems, which sounds excellent. But high recall can accompany more false positives, so builders need precision, calibration, and reviewer workload, not one flattering metric. Cisco positions Antares between rigid scanners and general coding models. It can adaptively inspect repository context, but deterministic tools still offer reproducible rules, mature integrations, and findings tied to known checks. Do not uninstall semgrep, CodeQL, dependency scanning, secret detection, dynamic testing, container checks, or threat modeling. Antares targets the localization stage. Every other layer still catches failures. This model was never designed to see. The practical pattern starts with an advisory, or CWE, runs Antares in a locked-down repository copy, reviews the ranked files and trace, then validates findings with deterministic tools and a security engineer. Before blocking commits, run the model in shadow mode. Compare its candidates against confirmed incidents, patched snapshots, and your existing scanners. Measure missed files, noisy files, latency, and reviewer minutes. Public benchmark repositories may not resemble your monorepo, generated code, internal frameworks, or obscure language mix. Build a private evaluation set from historical fixes, keeping test construction separate from model tuning. Even a read-only code agent should receive minimal permissions, no network access, strict command allow lists, resource limits, and isolated working copies. Repository text can contain adversarial instructions, whether intentionally planted or merely accidental. Localization is a useful handoff, not permission to auto-patch and merge. The model may choose the wrong file, misunderstand project behavior, or miss a second vulnerable path that requires a broader fix. Antares illustrates a broader shift. Useful local AI may arrive as many narrow models, each optimized for a measurable workflow, rather than one miniature assistant pretending to be excellent at everything. The next proof points are independent replications, patched code false positive results, performance on private enterprise repositories, hardware requirements across consumer devices, and whether the released models remain stable inside real, continuous integration pipelines. So yes, Cisco's tiny models are genuinely interesting. Local, open weight, specialized, and reviewable. Just keep the claim precise. Antares can narrow the hunt for known vulnerability classes. Your security process still has to finish it.